Hello class. Today we're going to look at evaluating expressions again, but this time we're going to use something to help us organize our data, something called a T-chart. Okay? So let's kind of review what we talked about yesterday real quick. Okay? Yesterday I gave you some expressions like this and asked you to evaluate them. So like take for example this first one. We'll just do this first one together. It says I want you to do 3x plus y. Well, the first thing you need to know is what does this mean? Well, it means I'm going to do 3 times whatever x is, and I'm going to add the value of y to that. So we look up here, we've got a value of x, we've got a value of y, so we're going to do 3 times x, which in this case is 6, plus the value of y, which is negative 5. Okay, well, we've got to go back to our order of operations and follow that. So we're going to do 3 times 6 first, which is 18, and then I'm going to add negative 5 to that. Well, when we remember, if our signs are different, we're going to subtract their numbers, and we end up with 13. Right? If we had this one actually means 2 times whatever x is, minus 3 times whatever y is, get an answer to all of that, and then divide it by z. Okay? So that's what evaluating expressions are all about. Okay, so when we evaluate expressions, we change the expressions and we keep the values of the variables. That's what we've been doing. I change the expression around, but I keep these values the same. Okay? Well, what if I gave you multiple values for one expression? Take, for example, evaluate this expression for all of these x values. Oh my goodness, that would be a lot of work, because that means I'm going to do 2 times 0 plus 3. Then I'm going to do 2 times 3 plus 3. Then I'm going to do 2 times negative 2 plus 3, and I'm going to get all different answers here. My goodness. There's got to be an easier way to do this kind of a problem. And believe it or not, there is. It would be nice if we had a way to organize all of our answers. And we do. It's called a T-chart. So believe it or not, this problem right here can be simplified to this problem right here. Okay? Where we can use this T-chart in order to organize our information. Now, in order for us to do this, we have to understand what this T-chart says. Because when I look at this T-chart right here, it speaks to me. You want to know what it says? Here's what it says. It says, if x is negative 2, then 2x plus 3 is what? So if x is negative 2, then 2x plus 3 is what? It asks a question every single time we want to do it. So what we do is we take this expression and out to the side, we actually evaluate that. 2 times negative 2 plus 3. So 2 times negative 2 gives me negative 4. And then negative 4 plus positive 3 gives me negative 1. Then this value is gone. So now we go to the next one. So if x is negative 1, then 2x plus 3 is what? So now our x value changes. We go 2 times negative 1 plus 3. So 2 times negative 1 gives me negative 2. Negative 2 plus 3 gives me a positive 1. Okay, so now those two x values are gone. So now we go to the third one. If x is 0, then 2x plus 3 is what? Well, 2 times 0 plus 3. 2 times 0 is 0 plus 3 gives me 3. Now the nice thing about organizing your data like this is you begin to see a pattern. You'll notice I'm going from negative 1 to 3. So the next one then should be 5, because it looks like we're adding 2 each time. And then the next one would be 7, and then the next one would be 9. It's as simple as that. So the beauty of organizing our data in a T-chart is it allows us to see patterns. And that's what we're going to be talking about for all of next week as well. Okay? What kind of patterns can we see? Okay? So let's see if we can do another one real quick. All right? What if I gave you this one right here? Okay? Oh, well, what does the T-chart say again? Let's see if you remember. Can you say it? Good. It says, if x is negative 2, then 3x minus 2 is what? Good. Now, you know what I'm going to do, I hope. Okay, anytime I see this minus right here, I'm going to change it. Okay, because I know I don't like minus. I'm hoping that you don't either. Okay, so 3x minus 2 is the same thing as 3x plus negative 2. Now again, the reason why I do that is to help prevent careless mistakes. Makes it just a little bit easier for me to understand. So I'm going to start with my first x value. 3 times negative 2 plus negative 2. Well, 3 times negative 2 gives us negative 6, because you know one negative makes it negative. So negative 6 plus negative 2 gives me a negative 8. Okay, then I go to the next x value. If x is negative 1, then 3x plus negative 2 is what? So 3 times negative 1 plus negative 2. Well, 3 times negative 1 gives me negative 3. And then negative 3 plus 2 gives me a negative 5. Okay? Then the next one, our x value is 0. So 3 times 0 plus negative 2. Well, 3 times 0 is 0, plus negative 2 gives me negative 2. So you'll notice that I'm increasing by 3 each time. Okay, so if I increase by 3 again, I end up with a positive 1. And if I increase by 3 again, I get 4. Okay? So when you're organizing your data in a T-chart in a systematic way, where you're increasing your x values by however much each time, the numbers on the right-hand side begin to form a pattern. Okay? So for once you've done it 3 times does form a pattern. Okay? So we end up just finishing it out with our pattern. Let's try one more, and then we'll be ready to have an assignment. So this one says, if x is negative 2, then negative 2x plus 6. So you think that negative, because this is the thing that's different here, do you think that negative will have any impact on the values? Well, let's see. So the first one, we start off with negative 2 times negative 2. Then I'm going to add 6 to that. Well, negative 2 and negative 2 make positive 4. Positive 4 plus 6 gives us 10. Then we change it to negative 1. Negative 2 times negative 1 plus 6. Well, negative 2 and negative 1 make 2. 2 plus 6 gives me 8. Okay. Then I go to 0. Negative 2 times 0 plus 6. Well, negative 2 times 0 is 0. Plus 6 gives us 6. So you'll notice instead of increasing by 2, this time what are we doing? We're decreasing by 2. So 10, 8, 6. The next one should be 4. The last one should be 2. Okay. Now, do you think we could ever use this kind of information in the real world? Well, let's see. Here's an example. It says Alexis makes wind chimes to sell at a local market. She uses the equation y equals 7x plus 10 to determine how much to charge for each wind chime. She wants to create a T-chart to help her determine what to charge for up to 10 wind chimes. Can you help her fill out her T-chart? Because if I know how much each of those, if somebody comes in and buys one, I know the price would be, for so much. Okay, it would be $7. Okay, but what if I had a customer that came in for 5 of them? How much would they be charged? Okay, so let's see if we can do this. Well, we know that this side right here is going to be our 7x plus 10. So we start off with one wind chime. How much is that going to cost? Well, we got 7 times 1 plus 10, which will give us $17. Well, what if they bought 2? Well, that'd be 7 times 2 plus 10. Well, that's 14 plus 10 gives us $24. Okay, well, what about 3? Well, 7 times 3 plus 10. Well, that gives us 21. Plus 10 gives us $31. And you'll notice that each time, what am I doing? I'm adding 7 each time. So the next one then should be $38, and then $45, and then $52, and then 59, and then 66, and then 73, and then $80. Okay? So if we actually do all of those, that's what our T-chart would look like. So we can actually use this information in the real world to help us determine various things. And it's just a way, a T-chart is just a way to organize your data. So what I'd like for you to do for your assignment today is you're going to be given a few T-charts that I would like for you to fill in. If I give you the expression, I want you to fill in your T-chart. Okay? Now in each one of these, I expect to see the work done for the first three x values. So I should see on this first one, -2 plus 4, -1 plus 4, 0 plus 4, and then you fill in the appropriate values here. And you do that on all 9 of these problems. Okay, until next time.